All right. So we continue off our discussion of lecture series number 5, which is computer software. And we're just going to wrap up the remaining segment associated with unit number 4, which is system software. And we're going to do the wrap up by just having a brief discussion of firmware and operating system software. Now, I should mention from the outset here that as you are researching online, you probably come across literature that will present firmware and operating system software as being the same thing. So, and fundamentally, the function that they perform is more or less the same. The main difference is however, that firmware is more specific, right? It's generally associated with a specific piece of hardware, while operating system software is generic, right? And the best way of thinking about this is to really think about how we tend to work with operating system software. So it is usually the case that one can install something like a Windows 10 operating system software on a machine or computer hardware manufactured by a vendor such as Dell, right? And at the same time be able to install the same piece of software, the same Windows 10 operating system software on a Lenovo Ideapad piece of hardware, or even an HP piece of hardware, right? And all that is possible because an operating system software is more generic, right? Each of these different pieces of hardware that I just highlighted, however, will have a specific firmware associated with them, right? So-called BIOS. So the BIOS that you find on a Lenovo Ideapad, for instance, is more specific to that particular piece of hardware. It wouldn't be able to run on a piece of hardware manufactured by Dell or HP, right? So the main difference really is more to do with the fact that one is more specialized and the other is generic. So firmware is specific to a piece of hardware, while an operating system software can be installed on different types of hardware. Just close that. All right. Right. So these things we are calling firmware, right, are nothing more than just low-level instructions whose sole purpose is to control a specific piece of hardware. And again, want to underline this phrase low level, right, by reminding us that we are in fact making reference to this whole notion or concept of abstraction, right? So low level because the instructions associated with this firmware are much, much closer to the native notation or native instructions that the computer will be able to understand, right? And in most instances, there will be a direct mapping between these low-level instructions and the machine code that will be executed by that piece of hardware. Also, this firmware is typically stored on non-volatile memory, right? Non-volatile meaning that it's difficult to change, right? It's permanent in most instances. And all this will make sense once we have our discussion of so-called primary memory, and specifically the type of non-volatile memory where you tend to find firmware is things like read-only memory or ROM. And in more recent times, it's on EEPROM or PROM, so programmable read-only memory and erasable programmable read-only memory. These are the sort of components where firmware is normally installed or embedded, right? And the reason is to make it somewhat difficult to modify those instructions, right? They're the lifeblood of the computer hardware. Without the instructions, the hardware would be non-functional. It wouldn't be possible for you to use that piece of hardware. So a common piece of firmware that perhaps most of you have interacted with, either explicit or implicitly, is so-called BIOS, or the basic output input system. This is normally associated with your average microcomputer, more specifically things like laptops and desktop computers, for instance. Although you typically find the BIOS on smartphones as well. So the purpose of the BIOS on PCs is to initiate the startup process. So when your computer is off and you switch it on for the first time, you typically are presented by that black window and some white piece of text, right? And after a few seconds, then your operating system loads or something. What's in fact happening behind the scenes is when you switch on your computer for the first time, right? The first thing that comes up is the BIOS, right? So the bootstrapping process itself involves the BIOS coming up or coming alive. And the BIOS is the one that actually boots up the operating system, right? So when you switch on the computer for the first time, typically you don't have access to the operating system. The operating system will be somewhere, it will be located somewhere on secondary storage or on disk, and the BIOS will then load it from disk. And then after it's done with the boot process, then you're typically presented with a login window that you use to provide the credentials, and then you are logged onto the system, and then you can then interact with application software, right? But for certain power users, right, it's usually the case that they'll interact with the BIOS to try and alter things like the boot process, right? So you change the boot order of the different drives associated with that particular piece of computer system, right? So what we mean here is that by default, it's usually the case that your computer will boot from the internal hard disk or hard drive first. But in the event that you want to change that sequence, you can alter those configuration details within the BIOS, right? So there's usually a sequence of keyboard keys that you use for you to get into the BIOS. Typically, the function keys would be used to do that. In certain instances, it's a combination of the control key, the alternate key, and I don't know, perhaps some other function key or something. But the thing I'm trying to say here is using the BIOS, you can alter the sequence. So, for instance, configure a computer system so that it first of all boots from a USB drive as opposed to starting to boot from the internal hard disk or hard drive. And I suppose one might ask why you might want to do that. Well, you'd want to do that if you say want to install a fresh copy of an operating system or a different type of operating system. If you were wanting to, your computer currently has the Windows operating system installed and you want to switch to Ubuntu, for instance, because Lighton has been talking a lot about Ubuntu, what you'd have to do is you alter the BIOS configuration so that you first of all start by booting from your USB drive, which will have the Ubuntu operating system software, right? Or you can configure your BIOS such that it first of all boots from the CD-ROM drive or the DVD drive in the event that your Ubuntu software is located on a CD or a DVD, right? You also tend to use the BIOS to perform management tasks like very rudimentary or basic diagnostic functions. So you can do fancy things like check for bad sectors on the internal disk, for instance. It's usually very helpful if there are problems, if you notice problems associated with your computer system. So as part of the troubleshooting process, you'd probably play around with the BIOS settings. And also another common feature or another common use for the BIOS system is certain security configurations, right? So you can configure it in such a way that the operating system is only loaded once credentials are provided, the correct credentials are provided. All right, so this slide just shows a sample screenshot of BIOS interfaces. This is actually one of the more modern BIOS interfaces. This is associated with an HP ProBook 520S computer. It's a laptop. I happen to have gotten this screenshot from my personal laptop. So I own an HP ProBook 520S here. Probably one of the best machines I've owned actually. It's almost 10 years old and still going strong. So you notice here that I can make certain basic configurations like reset the configuration to their factory defaults, perform diagnostics, right? set certain security configurations here. And I think as part of the supplementary materials, not I think actually, as part of the supplementary materials, a link to a very short YouTube video will be shared to showcase exactly how this particular BIOS, or the BIOS software associated with the HP ProBook for 520S actually functions. So it's a very short video that was taken, I think, last year or before last year. So it should be able to give you an idea of how this works. A point to note here, though, that the interface that you would probably see on your computer will be different from this particular BIOS interface. On certain Android devices, you typically get into the equivalent of the BIOS, so-called recovery mode, by pressing, again, this is specific to the hardware. On my OnePlus 3T computer, I would press the power button. I'll switch off my machine and then press the power button simultaneously with the down volume button, right? And then I'll get into recovery mode. And so from recovery mode, I can do fancy things like clear the cache or reset the operating system or something. All right, so as part of homework, or as part of a very short exercise, I thought it would be fun for us to go out there and try and see if we can find some other examples of so-called firmware and where they're used. I guess a hint here, or something that you find out as you are researching, is that most of these examples will be tied to a specific type of computer system that we discussed during lecture series number 3, I believe, which was computer systems types or categories of computer systems. And the particular type of computer system that you probably come across is so-called embedded systems. Again, I'll remind us of a key feature associated with embedded computer systems. There are generally single function devices. And so if it's a single function device, there's no point in having a piece of software that is going to act as a go-between, right? Why? Because you typically have just one application running. So there's no point in having an operating system. The firmware will typically do most of the dirty work. All right, so on to operating system software. So these are nothing more than just a collection of programs that are used to manage the hardware and application software. And again, the reason why you'd want to manage hardware and application software is because operating system will typically be generic, right? They'll work on a piece of hardware that will have a broad range of application software running, right? So give you an example of my computer system. For instance, I have a whole bunch of applications here. I have Dia open, can't remember why I opened it. I have a number of instances of the file manager Dolphin open here, right? So I have 4 instances of Dolphin open. I have 2 instances of Chrome open here. I have a text editor, I have a PDF viewer, which is Ocular, and I have vokoscreen, which I generally use to record screencasts, right? So, but the point here is that on a machine that is used for a broad range of tasks, you typically need an operating system so that it helps you manage these different applications that are generally executed simultaneously, right? Give you a sneak preview here. I'll just open a utility tool called System Monitor, right? You notice that it gives me an idea of the different types of applications that are currently running, right? So all of this, by the way, is possible, right? This management of the memory and CPU time associated with this computer system is done behind the scenes by the operating system installed on this piece of hardware. Right, so the OS will obviously just control the general operation of the computer, and provide some sort of mechanism that enables application software to interact with the hardware. Again, a reminder that application software does not have direct access to the hardware. It's able to access the hardware by going through system software. And in this case, the system software we're making reference to is operating system software, right? Another thing is that so-called operating system is typically stored on disk, just like all the computer software that you'd have installed or have available on your computer system. And it's typically the case that the operating system is only loaded into memory during the boot process. So again, remember our discussion with BIOS. The BIOS is the one that facilitates this bootstrapping process of loading the operating system from disk into main memory. Right, and I guess now would be a good time to ask the question, then if it's possible for application software to directly access the hardware, right, why then would we need an operating system, right, installed on a computer? Why not just have application software direct access the hardware? Well, it turns out that there are two main reasons why you need an operating system. Most of these have already been given away, by the way, but fundamentally, it's all centered around the fact that you have a number of things that would typically be happening on this piece of hardware, right? So think of the broad range of applications that you typically be running at any given point in time, for instance. Yeah. For you to be able to efficiently and effectively manage the resources, the finite resources associated with the computer system, you need an operating system software, right? So for my computer here to be able to share the RAM, the CPU time appropriately between all these different applications that I currently have running, I need an operating system, right? The other reason is that it's generally the case, or sometimes it's the case, that computer systems will have more than one user logged on, right? And so you need an operating system to be able to share the resources amongst the different logged on users, right? All right, so it turns out really that when you have applications running, multiple instances of applications running, you generally have multiple processes associated with these individual applications, right? So if I open up System Monitor again, you notice that I have several instances of Chrome open here. These are all different processes associated with the Chrome Chrome application software. You notice that if I close, and I don't want to close Chrome, but anyway, close it just to showcase example here. If I close Chrome, or if I exit Chrome here, right, just exit, you notice that System Monitor will soon no longer have instances of Chrome running. And I wonder if there's a way of, and there we go, they're going away. If you notice, they've been grayed out, they're slowly being, the processes are slowly being killed in the background or ended normally, right? Again, if I was to open up Chrome, what you will notice is that a whole host of processes, yeah, associated with Chrome will come up alive, right? So you notice Chrome processes here with their associated process IDs here, yeah. So if I can order them, I guess in descending order of the name, there we go, a whole bunch of Chrome processes here running on my machine, right? So the role of the operating system would be able to really share resources associated with this computer system appropriately between the different application processes. So it's not just the applications that are currently in primary memory, in this case RAM, that need to be managed by the operating system, but also the individual processes associated with each of the applications that are currently running. Right? So in this case, I would have processes associated with all these different applications running. And it's not just these applications here, there are also background processes that are running, right? And again, if I could just showcase, I can run the PS utility here to just list the number of processes running, right? So it gives you an idea of the range of, and I guess I should have said more here. So if I, again, just do more here, you notice that I have a number of processes that are running. and here is just the user ID of, I guess, the user that is running that particular process, right? So as I go down here, notice that there's a broad spectrum of really processes that are running in the background as well. So it's not just the processes associated with the currently executing programs, the programs that have been explicitly executed by the user who is light on here, but they are also background processes. Key thing here is that resources have to be shared in a way, right, in between those different processes and applications. Right, so screenshot just showing you what I just showed you, different applications and corresponding processes here. And again, if I could just do I guess a very basic analysis here to check how many processes, you notice that currently, as it stands right now, I have 301 processes running on my machine. Now, each of these 301 processes need access to memory. They need access to the CPU, depending on what sort of task is being performed, right? So it is the role of the OS, the operating system, to be able to manage the resources that these different processes would need for them to properly execute. All right, again, this whole notion of users. So if you have an application being associated with a broad range of processes, right, or having different applications running at any given point in time, then the situation actually gets more complex on a machine that has the capability to enable multiple users to log in at the same time. Usually the case for Unix-like operating system or server-type operating system software, right? You typically have multiple users logged on at the same time, and so you need a way of appropriately allocating resources to those different users that are logged on. You will soon see once we get back on campus and when we have access to Odell Laboratory that the setup is such that the terminals that we use in the laboratory are actually dumb terminals. So as students are accessing those machines, what they're doing is in fact interacting with a server computer system. Now, if you're doing that at the same time, there needs to be a way of appropriately allocating resources to the multiple users that would be logged on to the server at any given point in time. And the operating system is the one that handles all the gory details associated with resource allocation. All right, so again, an example on my computer system here, just showcasing that on this screen grab here, showcasing that there are a range of system users, right, that are accessing different applications at any given point in time. And again, if we can show an example in real time here, you notice this field, the username field. As I scroll down to access the other processes down here, you notice the different user here. I'm currently logged on as Lighton, but behind the scenes, there are certain applications which have specific users, user credentials or login users that are used to execute those particular applications and corresponding processes, right? So you notice that there are quite a number of processes that are being executed by the user root. Most of them are executed by the user Lighton, who happens to be the human being logged onto this computer system. But as I scroll down, hopefully I should be able to see much more than root and Lighton. So user MPD here, postfix. Yeah, so anyway, the bottom line here is resource allocation is done by the operating system. All right, but really, fundamentally, the operating system performs 4 core functions, right? Its role is to facilitate so-called file management, memory management, process management, and device management. And if you think about it, really, all these core functions are associated with the core functionalities associated with the computer, right? If you remember our working definition of an electronic computer system, defining it as being an electronic device that takes in input, right? Input, it takes in input data, processes the input data, and then outputs the the process data and optionally stores it on some storage medium, right? So file management would be linked to the storage of process data, right? You just don't store the data. There needs to be a way of effectively managing the data that is being processed. This could actually be associated with simple tasks like creating folders and storing files on specific logical regions associated with the computer system or the hard disk, for instance. The memory management would be associated with the memory. In this case, it's the main memory, primary memory, right? So the role of the operating system would be to manage the memory that would be needed by the different processes currently running on that particular piece of computer system. And then there's process management, which obviously is associated with the central processing unit. The execution of the different processes typically takes place on the CPU, right? And because the CPU has finite resources, there has to be a way to effectively manage processor time, right? Or manage the execution of those processes or instructions associated with the programs that are currently running. And then there's device management. It's typically associated with the input devices and the output devices, so-called I/O devices, right? So the role of the operating system would be to manage access to those peripherals. So think of what typically happens when you're using things like the mouse and the keyboard, the touch screen, if you use a touch, if you're using a smartphone, for instance. As you're interacting with those peripherals, the operating system behind the scenes masks out the gory details associated with device management. It turns out that this whole notion of device management is actually a complex process, right? So the operating system abstracts, or it abstracts all that for you. All right, so specific tasks really associated with these core functionalities are things like the operating system software providing this interface that allows end users to be able to interact with the computer system. So in my case, the interactivity comes in the form of a so-called file manager. So using this file manager, I'm able to interact with this computer system, right? I can browse or access data, right? Open files, for instance. I can search for data, right? Of course, this interface doesn't necessarily have to be GUI based, or it doesn't have to be a graphical user interface, right? Where you point and click, but it also takes the form of terminal application like what I have here, right? The only difference here is that you're not pointing and clicking, but rather you're mostly using text to interact with the operating system. So check how many users or which users are logged on here, right? List the processes or something. So you notice that using this particular terminal interface, I can pretty much do more or less the same things I do with the GUI-based applications. So what I'm able to do using the system monitor, I can do using the terminal interface. So, right, facilitate interaction with the computer system, also facilitates program execution, right? So the process is generally that if you want to run a piece of application software installed on your machine, you execute it by opening it up, right? Once you open it up, what typically happens behind the scenes is individual instructions, but the program is loaded into RAM, and then the individual instructions associated with that particular piece of software are actually executed on the CPU. Now, all that end-to-end process is performed by the operating system software. All right, and then in terms of file management, it's very basic file system manipulation operations like reading a file, right? Opening up a file so that you can read it like this. Deleting files, editing files, right? Yeah, and saving them to disk. These are all operations that are facilitated by the operating system. And then obviously when you have a broad range of processes that are executing at any given point in time, it could be the case that data might need to be shared between the different processes. So the operating system will facilitate so-called inter-process communication to enable different processes that are currently running to be able to communicate with each other and exchange data in the process. In terms of device management, it would be so-called, classic example would be tasks associated with I/O operations. All right, and then so there's also tasks associated with security, for instance. Remember, one of the things that perhaps most of us are familiar with when it comes to operating system or a computer system is we know that we have to log in, right? Type in your password, or if it's your phone, you specify the pattern that you use to log into your phone, or perhaps you use your fingerprint for you to log in. All of that is facilitated by the operating system software. Right? And then also error detection. It may be the case, actually happens more often than people think, that errors will occur on your, on your computer system. And so the operating system performs the role of reporting those errors to you. I don't know if people have experienced so-called blue screen of death or something. That would be a way of detecting and reporting errors. I wonder if I can access application for journal. Wow, I wanted to access logs here. Okay, I'll go to settings. I just want to see if I can quickly showcase. I wonder if I can access logs here. I can quickly showcase log. No. Okay. Okay, there we go. Cases log. Okay, system log viewer. I was trying to avoid using the terminal to check the logs, but you notice if I access that utility, because it's sensitive, I need to provide login details for the root user. What you will soon see is that as I'm viewing the logs here, I can actually select to see if there have been any serious errors that have occurred, right? You notice here that I have these errors. I wonder what was happening here. But the bottom line is that the operating system has logged these errors into the system log files to signal the fact that an error occurred, right? So an error was detected and logged, right? And there's different types of errors, as you can see. There are alerts, there are emergencies, but I guess in this case it would be like checking to see if there are any errors, right? And so if you were a power user, you'd actually investigate to try and find out what these errors were all about. That's besides the point, I guess. All right. It turns out that there's really a broad spectrum of operating system software out there, right? Some typical examples that people might be familiar with. Now, because I'm an old head myself, relatively old here, some of these examples are associated with specific versions of Windows that I used many years ago. But you notice that we have name brand like Windows, Linux, and Unix, and certain esoteric mobile operating system software, for instance, right? Like Android, for instance, Windows Mobile. These are just some examples. There are a lot more out there, right? But just to try and underscore the fact that there's a broad spectrum of operating system software available out there. The decision or choice of when to use them is generally dependent on factors such as the function or the use case associated with that piece of computer system. So for instance, if you are wanting to install the operating system on a server hardware, then you'd want to make sure that you install a server type operating system software, right? So Windows, for instance, has types of operating systems that are specific to server computer systems, right? So Windows Server operating system, for instance. These examples given here are specific to microcomputers, right? So Windows 2000, XP, Windows 7, 8, and Windows 10. All right. So again, it's the decision on what type of operating system to use is dependent on the particular use case. And really, if you think about it, this use case could pretty much be mapped onto the different categories associated with computer systems. So it goes without saying then that operating system software specific to embedded computer systems, specific to microcomputers, mobile devices, server computer systems, right? If you're interested in really getting an appreciation of just how vast this sphere of operating systems is, you probably want to go to this very nice Wikipedia page, or just Google up list of operating systems, and you come across this page here. You notice that this is by no means comprehensive. It just shows the different categories associated with this operating system software. Just to showcase the fact that there is a broad spectrum of operating system software here, I thought would provide some sort of background information associated with our case operating system software, which is Android. Remember, we said our case device is the Maono tablet. The Maono tablet is or makes use of the Android operating system software. And it turns out that Android is a Linux-like operating system software, right? So when you connect your device, if you connect your device onto your computer, and I hope this is going to work. So what I'm going to do here, by the way, is I'm quickly trying to see if I can connect my, and you can't see this because obviously I don't have a camera to showcase this, but I've just connected my phone to my computer. And what I'm going to do is I'm going to run a utility application called ADB, Android Debug Bridge, they call it. And I think as part of some practical hands-on, we'll probably play around with Android Debug Bridge. So I'll try and see if I can open my phone here using ADB shell. And you notice I'm inside my OnePlus 3T phone here, right? So I can run the same Unix commands like df here. If you look at the df output on my laptop, this is what I see. Notice that my file system has 457 gigabytes of space, and I have 20 GB available. If I run the same command on my Android phone, you notice that my Android phone has much space. Where is the Android? It's petitioned here, but you notice that there we go. Let's look at this storage. You notice that I have about 26 GB left on my phone, right? Android is nothing more than a fork of Linux. It's a Unix-like operating system, Linux-like operating system. At some stage, hopefully, we should be able to share PM. Okay, this won't work. Oh, I should have run it outside, I guess. ADB shell PM list PM. Okay, I guess this won't list. Okay, that's fine. I wonder why I'm forgetting these. I'm curious here as to what I'm doing wrong here. Don't know why. I wanted to see if we could list the ADB shell PM. Okay. I'm trying to see if we can list the applications that I have installed on my computer by using the Android Debug Bridge. And if I can just figure out what dump the name of the APK list libraries, so it's list packages. Okay, so I'll just say list packages, right? So there we go. So I run the list packages command, and you notice that on my phone I have this broad range of applications installed. Currently my phone has 252 applications installed. Now some of these are system software tools, some of them are specific to the manufacturer. If you notice, all of them with the namespace 1+ here, these are manufacturer applications. But you can see from the list that I have applications such as the Quora app. I have WhatsApp installed on my phone, right? This is good stuff. Okay. All right. But the bottom line really here is that you can pretty much trace the history of Android, or the family tree of Android, to Unix, right? Unix has a number of variations. So there's BSD, so the likes of FreeBSD, for instance, which I had the opportunity to play around with many years ago. But oh, there we go. There's FreeBSD here. Also, for those of you with Macs, you'll be glad to know that Mac OS is actually a fork of, it's a Unix-like operating system. So on Mac, you can run some of these commands that I'm running, like ls, for instance, or pwd to present working directory. Right? Great. So just to quickly just try and draw comparisons between some of these things that we've discussed, right? One would ask then that what are some of the similarities and differences associated with system software and application software, right? And this is probably second nature by now, looking at how extensive our discussions of system software and application software have been. But fundamentally, remember that system software will generally be used to directly interact with the hardware, right? While application system software is used for performing generic user tasks. It's also the case that system software has direct access to the hardware, but application software does not have direct access to the hardware. Application software has to go through a specific type of system software, which is operating system software, right? So it goes without saying here that end users will mostly interact with application software, although in certain instances, so-called utility software tools, which is a class of system software, will be used by end users, right? Some other, I guess, things with discussion here, the fact that generally speaking, application software would tend to be installed only after you install a specific type of system software, and that's the operating system software. So if you're wanting to use Microsoft Word, for instance, and you don't have it on your computer, you cannot install it before installing the operating system software first. Right? And obviously, this is a no-brainer. Application software is dependent on a specific type of system software, which in this case is operating system software. Right. All right, so this diagram, I guess, best summarizes the relationship that exists between system software and application software. Typically, you have an end user that interacts, for the most part, with application software, and the application software goes through the system software, which is typically operating system software here, in order to perform a particular action, in order for the hardware to perform a particular action, right? In terms of the broad categorization and subcategorization of the different types of computer software that we looked at, I guess this block diagram best showcases a sample hierarchy of application software, right? So we notice that application software is a class or a type of computer software. It has a number of categories or subcategories associated with it, right? Desktop-based applications, web-based applications, scripts, libraries. We have special types of application software that enhance the functionality of existing software. So things we are calling add-ons, extensions, plugins, modules, right? And of course, I mean, we know that these enhancers, things we are calling enhancers, can pretty much be associated with desktop applications or web-based applications, for instance. So maybe this hierarchy could have come somewhere here or something. But we're just highlighting the fact that they are just a type of application software. And then in terms of system software, we've just discovered that we have different categories, right? We discussed firmware, operating system software, so-called language translators, and utility programs. In as much as we can further subcategorize things like firmware, operating system software, and utilities programs, but it's worth mentioning here that if we look at language translators, we can try and think of the subcategories associated with language translators as being things like assemblers, disassemblers, compilers, decompilers, interpreters, right? We discovered that utility programs associated with analysis, management, configuration, right? So we can further subcategorize utility programs based on those different functionalities. All right, so just to recap on system software here, we had a really lengthy discussion on these 4 broad categories of system software. Utility software tools that are used to monitor and manage a computer system, right? Language translators that are used to convert one notation into a different but equivalent notation. We had a discussion of firmware, which is a type of software composed of low-level instructions typically used to control a specific type of hardware. And then we wrapped up by having a thorough discussion of operating system software to gain an appreciation of the core functionalities performed by operating system software. Now, if it was a different type of course, we were probably going to go into the gory details of trying to look at the different modes within which an operating system operates. So things like kernel mode and user mode, but we're not interested in that. Our discussion for this course is solely restricted to the key functions associated with operating system software. And in actual fact here, we are setting the stage for subsequent discussions where we are going to have more in-depth lecture series associated with file management when we look at computer storage or computer memory, right? Device management when we look at the I/O subsystem. Process management when we look at the central processing unit in depth, right? All right, so in the next unit, we're going to discuss computer program execution to try and tie the discussion of computer software together. All right, thank you. I'll see you in the next unit.